in this video we will discuss TCP communication flags. In TCP communication there are 6 important flags. I am talking about the important flags that help to manage the connection between two devices. These flags are actually 6 bits in the TCP header and each one has a special purpose. So we will discuss those 6 flags one by one. Okay, these are the 6 flags. So let's discuss. The first one is the SYN. SYN is shortcut for synchronization or synchronize. This flag is used to create TCP connection to initiate the connection. Second one is the acknowledgement or ACK, which is shortcut for acknowledgement. This flag is used to acknowledge the reception of SYN data. So it will acknowledge this SYN data. I will show you in the Wireshark as well. Then let's discuss the push one. So push, this flag is used to instruct the receiver device to deliver the data to the receiver application as soon as possible without buffering it. So it forces immediate data delivery without buffering it. For that purpose, we use this push. Similarly to the push, we have the urgent one. It should be on the top here. Shortcut for urgent. When this flag is set to data, the data will be processed immediately compared to data without this flag to set. So it will be processed before any other data. So there is a difference between urgent and push. Keep in mind. Then we have a fin. Let's go to fin. Fin means finish for shortcut. This flag is set when finishing the TCP connection. End of data transmission, then the TCP use fin. Similar to fin, we have a reset. This flag is set when TCP connection need to be terminated. Immediately, setting this flag will drop any transit data too. So again, there is a difference between reset and fin as well. So this is all about the 6 important flag. So SYN flag is set when connection is initiated. The ACK flag when the segment acknowledgement of the SYN packet. The fin flag when the connection is terminated. The reset flag when the connection is aborted. And the push flag when the data should be delivered to an application as soon as possible. And the urgent flag when the data should be processed before any other data. So there is a difference between push and urge, and there is a difference between reset and fin. So now we know these, okay, and these are the detail. This is the header of TCP. There is a source port, there is a destination port, there is a sequence number, there is acknowledgement number, there is a header length. And these are the, the flags, which is 6-bit. I told you this is 6-bit flags. Here is 6-bit, which is this one is urgent, acknowledgement, push, reset, SYN, and fin. Then we have a window size. Then we have TCP checksum. Then we have urgent pointer. Then we have options and a data. So the TCP header is 20 to 60 byte segment containing control information for reliable data transmission. The header ensures reliable order and error checking communication between the devices. So now we know theoretically. Let me show you in the lab. So I already captured a packet in Wireshark to show you all these flags. And then we will discuss the header. Let's discuss the header first. So let me this flag. Okay, so here is the TCP. Any of this packet of TCP, and this is transmission control protocol, and let me make them like this. And as better, let me do it another thing. Let me take a snapshot of this one. So we discuss about the header. Here you can see the header. Okay, so in the header, as I said, there is a source port, which is random port. There is a destination port. Okay, there is a sequence number. Okay, there is acknowledgement number. These are the flags which we were talking about. There is a flags as well. Okay, and there is a window size, and then we have a checksum. It should be here. We have a checksum. Urgent pointer. There is a urgent pointer as well, optional. And then we have a timestamp and other detail. So this is the port of the sender, source port, destination port, port for the receiver, okay, which is 60020. This is the header of TCP I'm talking about. Then we will move to the flags. Then sequence number. This is a sequence number. Sequence number, key, packet and order. In case if there is any drop, so it will retransmit them. Source port and destination port, we know, we already discussed about the port. So this is source and destination ports. Then we have acknowledgement. If there is confirmation required for any data, so it will be used. Acknowledgement number, in this case we have 0. And then we have a flags which we will discuss a bit later, where you will find the start and reset, those flags which we discuss. Then we have a window size 1024, how much data can be accepted. Then we have a checksum for error checking. Then there will be urgent pointer, which is optional. I told you, if you go back to the header, this is optional. And then we have the data or padding, which is also optional setting, max segment size. So this is all about the header of TCP. You can see a lot of other thing as well. Okay, so now we know about the header. Let's come to the 6 TCP communication flags. Okay, so we discuss about 6 flags. These are the flags like a SYN. So what I can do, let me put here TCP SYN. Okay, so I said the IP address is 192.168.1.3 and the TCP flag is SYN flag. So let me go here, and here you will find the SYN flag. Let's go up. It should be, there should be, yeah, this is the SYN flag. And if I go to the TCP header, so this is the TCP header, and inside there is a flags. Let's open this flag, which is a 6-bit. And inside, if there is anything 1, it means this is set. So you can see, let me take a screenshot of this one so it will be better. Yeah, here you can see this is 1. And SYN, which is synchronization, is set. And you can see there is other flag as well. We are interested in FIN flag, we are in reset, we have a push flag, we have acknowledgement, and we have urgent. So 1, 2, 3, 4, 5, 6. We are interested in these 6 flags. Right now I show you the SYN synchronization flag, which is set, and here you can see 1. Okay, so we saw the SYN flag. The second flag which we want to see, acknowledgement. So I would say acknowledgement. I will change this to acknowledgement and filter this one. So here is the acknowledgement, and here now you see acknowledgement is set here, and also 1 is there. Previously the 1 was under the SYN one, and now it is under the acknowledgement. So you will see 0 or 1. Okay, 1 to set. Okay, and also you will see set here. This is not set, not set, not set, not set. Here you can see these is say not set. So here you can see the acknowledgement is set. This is the acknowledgement flag which we discuss. After the acknowledgement, I want to see there is a push one. So let's jump to the push one. Okay, we discussed about the push one. So now you can see push is set, and here we have one. So this is the push one. Okay, and let's go down. Acknowledgement, we check out, there is a fin. So if I click on the fin one, so you see the fin one is set, and also the acknowledgement one is set, because this is fin acknowledgement. So both are set. You can see set, and also the finish, you see. And there is a reset. So if I click on the reset, and here you will see the reset is set, and this is 1. Okay, and finally if we go down, so you can filter by here, and also you can check. So we left push one, so let's go to here. Yeah, so now we have the push one. Let me take a screenshot, is better, so that I can show you. Here is the push one. Okay, and which is set, and also there is fin one which is set, and there is urgent which is set. So urgent one, okay, as we discuss, and there is a push, there is a fin, send we already done, and acknowledgement we already done. So you can easily find out in the TCP header. So this was all about the 6 important flags: urgent, acknowledgement, push, reset, send, and fin, which is a 6-bit reserve. Okay, and we saw in the header as well. Also we check out the source port, destination port, sequence number, acknowledgement number, window size. Urgent pointer was there but optional, and this was there but not set, and it was not in use. So you can see here. Okay, if we here, and here is urgent pointer is 0, you can see. Okay, so this was all about the 6 important TCP flags.